Hello world.
All right, go for it. Oh, is the music off? Let me. I will leave this. Oh, sorry, I got it. Okay.
All right. Can everyone hear me? Okay. Well, welcome everyone. This is our first meetup, so we're happy to see you guys. So in case you're wondering what this all is, this is MetaX, and MetaX is a blockchain dApp and protocol development studio. Originally, our team started off as Vidroll. Vidroll is an advertising technology company. And through our experience with Vidroll, we learned that there were a lot of problems with digital advertising. And when we were exploring solutions, we came across blockchain. And 2 years ago, we started to experiment with the Bitcoin blockchain and to see if we could potentially solve these digital advertising problems with this new technology. And when we realized that, yes, this is a viable option, and yes, there's a lot of value to bring to the digital advertising industry, we saw the endless opportunities to build dApps. And that's when we said, let's do MetaX, and started talking about all the different projects that we're currently working on, because we're really excited about it, and we wanted to bring in you guys and get you guys really excited about it, because I think we all share the same excitement. All right. So AdChain, I'm going to give you a quick presentation on our first protocol project called AdChain. Thank you. So how many people know anything about ad tech or digital advertising, the way it works? 3, 4. So one person, not our team. I really hope we know ad tech. So ad tech is really complicated. There's a lot of different technologies and there's a lot of people involved. And because of that, there's a lot of issues. So I'll get into that here. But we've been working with Microsoft and Consensus for the last year now to develop the AdChain protocol. It's still in development, but we're seeing great progress, and we have a production-ready dApp that we're already testing in a live production environment. So why are we building AdChain? There's a lot of fraud in online advertising. And in $175 billion a year industry, roughly $8 billion goes to fraud. And what is fraud? There's a lot of different types of advertising fraud, and we attribute these different types of fraudulent activities to the lack of transparency in the industry. So oftentimes, an advertiser doesn't even know where their ads are being served, and more often than not, the ad is not even seen by a real person. So these botnets are just siphoning revenue from the advertising industry. These problems are exacerbated by our industry's continuous growth. Every year, our industry gets bigger and bigger, more ad tech companies join, the supply chain gets more convoluted and opaque. And this continues to put strain on what we call a flawed backbone. Because it's clear, after learning everything about online advertising, that there needs to be a new infrastructure. There's an interoperability problem, there's an open access problem, and the more we learned about it, the more blockchain became clearly a solution. So this is a slide that represents the advertising supply chain. And this represents the opaqueness of the supply chain, because beyond the first hop of your relationship with your partner, if you're an advertiser, Coca-Cola, you use a technology called a demand-side platform to deliver your ads. And you also work with what we call safety vendors to verify that these ads are legitimate and that you're serving ads to real people on the web or on a mobile device or a smart TV. Oftentimes, to achieve scale, these DSPs or demand-side platforms work with exchanges. Exchanges essentially aggregate all of the supply in the industry or the available impressions for advertisers to buy. In order to get this scale, exchanges work with multiple publishers. And then there are, of course, ad networks and aggregators that aggregate publishers. So you can see how this just extrapolates down the chain and it gets more and more opaque because there's no KYC element in our industry. So by the time you hit the publisher's webpage, it could be 12 hops removed from the source of revenue or media spend. And with net 60 terms, the advertisers have to pay out, and nothing good happens from trade to settlement. And a lot of that revenue goes to the wrong places. And by the time settlement occurs, it's a mess because the publishers don't get paid what they should get paid, and a lot of the revenue is going to the wrong places because a lot of the aggregators are nefarious actors that are exploiting the system in general, and they masquerade as legitimate entities. So, going back to the different types of fraud, there's also malware that originates not on the supply side or the publisher's page with botnets, but it actually code nefarious scripts are injected somewhere in the campaign, in the supply chain, and this malware is delivered in these malicious ads, and they can actually hijack end user's computer, holding it for hostage, but also doing different types of nefarious activities. So we asked ourselves, what if we just continue to develop new advertising technologies and product? We continue to add value to the industry, but after understanding the problems, we saw that if we did nothing, if we continued to just work within the same protocol, if you will, it's kind of a scary future for our industry. And our industry as a whole is becoming more centralized around just two companies. And these two companies were responsible for 99% of the advertising growth in Q3 of last year. So as an independent ad tech player, going against these two companies in an industry that is riddled with fraud, we're like, let's just go to a protocol DApp development route with AdChain and solve all of these problems using a different technology. So, as I mentioned, we learned that blockchain is a potential solution, but it's not the specific solution for our industry. So that's when we tailored AdChain, which is an Ethereum-based protocol, to seamlessly integrate into the current systems that make up the online advertising space. So what makes AdChain special? It's the development that we've done jointly with Consensus on top of the Ethereum blockchain. And one thing we wanted to make sure we made our technology adoptable. Overall, our objective is adoption. So we use simple beacon tracking, which is how the current industry operates. AdScript is our unified and consistent blockchain language that is tailored to the advertising industry. And this allows all of the entities within the supply chain to participate, but also to have this universal language. And then our AdChain matrix. And this is when things got really exciting for us. When we first tackled the scalability issues, we started to develop off-chain. And this is really the core of tonight's presentations is about developing off-chain. So we'll get into that. But the AdChain matrix allows us to execute massive transaction volumes while maintaining integrity and security. So clearly, blockchain doesn't scale. We all know that. But our industry, on advertising, we process trillions of events a day. So in order to have a viable blockchain solution, we needed to do it at scale. So going back to the same diagram, now we get to see add chain here, add script, add chain matrix. And what we do is with beacon tracking, each ad server within the supply chain uses the ad chain tracking beacon. So this beacon fires, it's encrypted, and then it's stored in Ethereum. The safety vendor verifies that that impression event is legitimate, and then the ad is served. So because of this simple model, there is 100% transparency now in the supply chain. So how does this new transparent protocol have the ability to potentially solve fraud? Well, with a richer data set, it's ubiquitous across the entire supply chain. So everyone is looking at the same data, the same events that occurred that they are being paid on. And they all verify that these impression events happened. And if the safety vendor that works with the advertiser's ad serving technology deems that this impression event is illegitimate or fraudulent, then the advertisement isn't served. So this is what we've been presenting for the last 3 months to the online advertising industry, and we've been receiving overwhelmingly positive feedback. And we're starting to work now with the industry's leading trade organizations, like the DMA, the IAB, and TAG. And what those acronyms stand for is the Data and Marketing Association, Interactive Advertising Bureau, and then Trustworthy Accountability Group. And these are the leading trade orgs in our industry. So that's that chain. And now I'm just going to hand it off to James Young, who's going to take us off chain.
Awesome, thanks. All right, just need a quick second to switch up slides. Thanks everyone for coming tonight, and I appreciate everyone's time. So hopefully by the end of tonight, you'll be able to get a perspective as a web developer or someone that would like to make dApps, be productive, and be able to start dApp development. So. All right, can everyone see that? So hopefully, again, this presentation will be informative and equip you to start building dApps or get an approach to understanding how to develop dApps. I want to give a shout out to Jem, Micah, and Joseph for their involvement in blockchain and Shane as well. And what we really want to do with these events is to really build a community here in Los Angeles. And so we want to give back and hopefully spur good conversation, innovation, get people excited about blockchain and what we're doing, and help spread the word. So without further ado, we're going to talk about dApps. So what is a dApp, first of all, right? A dApp is short for just a decentralized application. So who knows what a dApp is or has heard the term? Okay, so a lot of you. You know, as coming from a web developer perspective, you can think of the blockchain as pretty much your application server and your database kind of combined into one. So you don't have to worry about like the server side of things. And I'll walk through a quick example. So let's take a simple game of tic-tac-toe, and we're going to do this on-chain. And you know, as Ken mentioned before, when we first started looking at blockchain development, we're like, okay, let's see if we can build this on-chain. And so here you have player 1 and player 2. They want to play a game of tic-tac-toe, and they want to interact with the blockchain. So player 1 says, okay, I'm going to initiate a smart contract. Player 2 says, okay, I'm going to play with you, and the game begins. And so player 1 makes a move. The code, the application logic for the tic-tac-toe game is happening in a smart contract encapsulated in the blockchain. And is verified, and then player 2 then also makes their move, so on and so forth. So you move on, and let's assume now that player 1 has made the winning move. And so the blockchain says, okay, great. Player 1 has won, and everything is settled. So when we were looking at on-chain development, when it comes to building dApps, we saw that there were a few considerations. first off, as Ken had mentioned, there's an issue of scale. So when you're building dApps, it's still very early days, and it's very easy to kind of overwhelm a blockchain. So, for example, when we look at blockchains, specifically just from a cryptocurrency perspective, and think about them as transactions or transfers of value, you can see that the Bitcoin blockchain, give or take, can do about 5 transactions a second. Ethereum blockchain can do approximately 20 a second. And so when you compare this to mainstream networks, like a credit card network like Visa at peak can do about 25,000 transactions a second. You see there's an order of magnitude issue when it comes to scalability. But as a web developer, we think about things in larger scale. So when you compare this to something like Facebook does about 100 million requests a second. So there's just a different orders of magnitude when you're looking as a web developer to start making dApps. There's also some other considerations. So this is specifically with the Ethereum blockchain. Every time you want to compute something, it costs money. It costs gas for computation and storage. And if you have a lot of logic in your smart contract or you're storing a lot of data, that could be an issue, because for each block that gets mined, there's a 4 million gas limit currently. And when you think about the computation and blockchains, you have to think about the consensus and the blocks that get mined. So on Bitcoin, a block gets mined around once every 10 minutes. In Ethereum, it's about once every 15 seconds. So you're like, great, as a web developer, this is more like blockchain. And so when we were looking at this, we were like, okay, we can either, wait a few years until this issue is solved, or try to figure out another way. In Bitcoin right now, they're going through this block size debate, and they have been going through it for a while, which is pretty interesting. I know Ethereum has wanting to move to consensus from proof of work to proof of stake. So that's really fascinating and it's interesting. And so what we said was, what we wanted to explore is there a way that we can continue like web scale development for blockchains while maintaining blockchain-like characteristics. And so this is what we're calling off-chain. And more than anything tonight, I think that I hope the message that you come away with, if anything, is just that there is an approach to off-chain development, and that there needs to be more research, there needs to be more innovation in order to be able to start dApp development. Because unless there are feasible off-chain implementations, it's going to take a while for dApp development to happen. And for us, we really want to encourage that. So I urge everyone here to look at these different off-chain projects. Notable at the end is Secure Cryptlets, and Eugene from Microsoft is going to be talking about Secure Cryptlets, which is pretty exciting. And so for us, when we were trying to decide, okay, well, we know that we need to be able to go off-chain. How can we approach this, as an engineer, trying to problem solve? And one of our high-level approaches is to say, okay, well, let's separate application logic from transaction logic. And so this was really fascinating to us, because when we're saying, okay, if you separate the application logic from the transaction logic, that gives you this benefit of being able to code in whatever language you're already used to. So you can leverage your skill set that you already have and use tools that you're already familiar with. And we're sort of like, great, this is awesome. And it got us pretty excited and wanting to continue and explore how can we further along off-chain development. But with everything, there's always a catch. And so what we are looking at when it comes to off-chain development, and what we're examining is, can we do off-chain, and can this problem be solved by looking at this as a design pattern update, where we can keep blockchain characteristics. And specifically, what I mean is, as a web developer, as you're creating your application logic, can you update your design pattern so that every transaction, everything that you're doing is a log that's verifiable? So one simple approach for us that we are looking at is being able to start a transaction on-chain. So you memorialize what you're doing on-chain, and you end on-chain at the end. So you start on the blockchain and you end on the blockchain, but essentially it's like opening up a channel and then closing a channel. Everything else is off-chain. So you're like, okay, well, great, but you're not using the blockchain for the off-chain portion of what you're doing. So for us, what we are looking at is how can we replace essentially the consensus mechanism and the blockchain. And for tonight, just going to walk through a simple example. What you do is when you have two players, for example, in the tic-tac-toe game, you don't necessarily need consensus because consensus is required for 3 or more participants. What you do have, though, and what replaces a blockchain is this, what we're calling a trusted judge. And so this trusted judge helps if there is a dispute. So going back to the tic-tac-toe game, you have player 1 that communicates with the judge and player 2 that communicates with the judge as well. The judge is a proxy and starts the smart contract. And essentially this judge is essentially just a socket server. And so what happens is player 1 and player 2 both have a copy of the application logic from the judge, and the judge also has a copy. And so when you start the game, player 1 signs and verifies that they've received the code, the code, and player 2 can verify through a hash that it's actually the same source code. So player 1 sends over to the judge their move, the judge just relays it to player 2. Player 2 then replays through its transactions, and this is the design pattern update, verifies that everything is good and says, okay, well, I'm going to now make my move. Sends it over to the judge relays it over to player 1. Player 1 does the same thing. Fast forward to the end of the game where player 1 is making the winning move, sends it over to the judge. Player 2 verifies that that move was correct and it has won. And then the judge just closes out the channel, and both participants, winner and loser, gets paid whatever they bet in this tic-tac-toe game example. But, you know, what happens if someone cheats? Well, going back to the example where the judge initiates the smart contract, let's say that player 1 is cheating. It gets relayed over to player 2. Player 2 sees that there's a discrepancy in the hashes. It notifies the judge. The judge then can replay all of the transactions from the beginning and checks for the matching hash. And in this instance, the judge sees that, or has decided that player 1 has cheated and pays out accordingly to the rules of the smart contract. So what this boils down is that, you know, each transaction needs to be replayable for verification. And that's a core of this design pattern, to be able to start being able to deploy off-chain decentralized applications that have similar trust characteristics as a blockchain without having to go on-chain for every move. And what we're doing tonight is we're open sourcing just the tic-tac-toe game. So you as a developer can take a look at the code, run it, and play around. So after the end of all the talks, if you've brought your laptop, and we'll put this URL to the GitHub repo up again, please feel free to tinker with it and play around with it. We also have worked with a startup called Lunch Badger, and Al is going to be able to present to you in a bit more detail this tic-tac-toe implementation. Question?
By bringing in the judge, aren't you disturbing the fundamental God protocol of blockchain? Because that becomes a central character which we are trying to away from.
That's very observant. Very good. That's a great question. So that's why I said it's a trusted judge. And for the purpose of this presentation, just to simplify things, you're right. You know, it's centralized. And I can talk in more detail about how you can provide better trust or security guarantees by having a marketplace of judges. And then you just need to be able to show and prove that there isn't collusion between the judge and the players. Because to your point, you know, how do you know if player one has really cheated, or if the judge and player two have colluded together to blame player one? So, you know, this is a part of active research that we're doing, and we're really excited about it. And this is why we're, you know, presenting.
You're saying the judges are also like a blockchain themselves, on a parallel blockchain kind of stuff.
They're not a blockchain because there's no consensus. What they're doing is just verifying transaction hashes. So, yeah, but we can talk about it in more detail. But this is a great question.
So you're shifting the scalability from the official nodes up to the judge, which is more limited in what it has to deal with. And it's more efficient because it doesn't have to do everybody's transaction, just your own.
That's right. That's right.
So
that's exactly right. We're offloading the compute, the application logic, onto these servers, or these judges.
So couldn't you just limit the scope of what the actual node is or something?
Well, so we don't have control of the Bitcoin or the Ethereum nodes or the miners. So unless we wanted to rally and make updates to the Ethereum protocol, which may take a while to happen. And I think that's why, like with Ethereum, they're moving over to proof of stake to make it more fast in terms of the mining times and scalability. But yeah.
Are you saying each judge is like a compute node?
Yes, it could be one server or a cluster of servers. That's right.
So does the judge do proof of work?
No, there's no consensus. It's just verifying hashes. In the back.
As a clarification question, when you talk about a marketplace of judges, does that essentially mean that it decreases the likelihood that there could be collusion because you have to collude with the entire marketplace in order for something?
That's right.
to happen?
That's right. So it's kind of like it's not the same as, but has similar characteristics of like a 51% attack. What are the chances that if I'm player two, I'm also controlling a few of these observers or these judges? And so as long as you can, there's, I guess, proof of non-collusion. And like you said, the larger the marketplace, the less likelihood of you being able to be matched with your own observer if you're playing.
How do you incentivize judges to participate in the marketplace?
That's a great question. I think really that's going to be based on the context of your decentralized application. And I think this is one of the things also that we think hard about when it comes to blockchain development and dApp development. There's a difference between it being technically sound and reasonable and the game theoretics and the economic incentives and the alignment of those incentives. So there's an extra dimensionality to development because the way that the incentives are informed based on what you're doing can impact design. So this is where it's like, as a developer now, as a web developer, okay, you have an opportunity to do this off-chain, but you also need to understand and take better context, because now you're not just transferring data, you're transferring value. And so there are these like incentive mechanisms, this gameplay that happens that you need to be cognizant and design for as well.
So you can't tap into the gas part of the Ethereum to...
If you're going off-chain, you don't pay any gas. Yeah.
But if you're doing it, could the judge actually grab some extra by setting his price higher?
The judge, yeah, so I think there are implementations that can take in an account of like an observer tax. So that could be a mechanism for incentivizing people to want to be judges, and maybe depending if it's like tic-tac-toe, it's a low-stakes game, maybe the tax isn't as high, but if it's like high-stakes poker, for example, maybe the stakes are really high. And you want to have many observers, and being able to verify amongst not just one observer, but having multiple observers. Because then now you're not having to just worry about one observer colluding with a player or a group of players, but a breadth of observers colluding together.
Yeah, quick question. So, I mean, my understanding of this is kind of somewhat like how Lightning Network works with Bitcoin blockchain in a certain sense, but I mean, my understanding in that case is that it's sort of just a 2 of 2 type transaction that then, like, so could something like that work here, where the parties just sort of verify that each other made the correct moves in the game, and then it's kind of obvious if either one's cheating?
That's right.
I guess, like, what's the failure mode of that necessitates having the judge?
Not knowing who is, like, I could be falsely saying that your hashes are incorrect. Okay. So it's a he said, she said situation. So you need a tie break. Yeah, yeah. Great questions. These are awesome questions.
What is Ethereum's goal as far as the number of transactions they can handle per second?
That I don't quite know. I think that there is a lot of research going on right now with proof of stake and sharding, and it's kind of beyond, honestly, the scope of my kind of limited understanding of crypto. I'm coming from like web development, ad tech, and so yeah. But yeah, I would love to know the answer to that question as well. Great. Well, I'm very excited for everyone and all these questions. And again, feel free to, and I'll post this up at the end, to be able to take a look at tic-tac-toe. And I think just to kind of dive into the weeds a little bit more, we have Al that is going to present the actual off-chain implementation of tic-tac-toe in a little bit more technical detail. And we just need a couple of minutes while we change computers.
So while we take a few minutes, we have
All right, thanks, James. How many of you, I'm just curious, how many of you guys are web devs? And for the folks that don't have their hands up, just quick shouts out. What do you guys do?
QA.
QA, nice. You? Yep. PR. PR, yeah. Nice. Always a good thing. You, sir? Yep, you? Finance. Finance, nice. So I'm just curious, what brings you to an Ethereum workshop?
Here with a friend.
It's a good reason. Free food, free booze, right? So one of the things that has got me excited and interested in this, I'm not part of the Ethereum anything. In fact, James and I, we're longtime colleagues by like N degrees of separation. And we're lucky enough to be the thing that actually powers the workshop that you guys will be able to clone and actually run. So I'm the CEO, founder of Lunch Badger. This is our team. And we are newly minted, so we just got seed funded like 3 weeks ago. But we've been working with Ken and James on something really exciting, because the thing that got me interested in actually participating and anteing in our company resources into this is this changes everything that we know of in ad tech, in finance, heck, I don't know, maybe even PR, like the United Arab Emirates, right? Like the prince wants to get everything onto the blockchain. And you think about it, why? It's because transparency is a really powerful thing. And what we're trying to do is bring the tooling up to that transparency level for technology. Ethereum is great. And if you read some over my blog posts, and God forbid if you would read some of the ones that I redlined, you'll see a lot of expletives. The tooling is horrendous. It's so nascent. I mean, the promise of what blockchain can do is one thing, but getting there, not quite there. And that's where we've come in, and we've kind of wanted to seize the opportunity, and we thank our VidWorld partners for doing that. So what is Lunch Badger? Well, it's real simple. It's API, microservice APIs in a box that you can take with you. So if you're familiar with companies like Apogee, or back in the day, Mashery, or the ones that are about to go public like Mule, these are companies that are 8 to 10 years old, and they solve the problem for the enterprises, which is great, but it's not really generalized for the kinds of use cases that we're doing now. And the thing that we're latching on is to say, look, APIs and microservices apply to everything. And what's really exciting is, most especially for something like dApps. And why? It's because when you think about a blockchain, you think about all that nascent tooling. You think about this thing called Solidity. I didn't even know what Solidity was until like I sat down with James looking over this crazy stuff. And there's this amorphous general public ledger that people want to get their stuff into and figure out how to use. And then you have folks that are like web devs, like myself, and other folks that, yeah, we can kind of build code and stuff like that, but what's the drawbridge to getting into Ethereum? What's the way to get to the promised land of what this thing unlocks and be able to disrupt the ad chain space, like what Ken and his team wants to do with that, with ad chain and ad tech? So we're all about making that easier, and what we've done is we basically built a solution to do that. Our tagline is "Eat your competition for lunch," and we have we call him CLB, cheeky little bastard, because, well, we're all about the audaciousness of beating your competitors with a superior experience, cloud-native tools, and stuff that really powers like everything that we want to do for next generation web, mobile, or IoT. And it's just a tagline, but it's one of those things that really challenges the company just to say, look, if I'm building a website, or if I'm building a mobile app, or if I'm building like my little Raspberry Pi, whatever the heck, you're really building an API at the end of the day. You probably didn't think of it that way, but then that aha moment is like, oh yeah, like that same function call into that remote server, that's just an API. And if I actually surface that out for the rest of my ecosystem to use, well, gee, imagine what you can build as an ecosystem of functionality, partners, customers, you name it. That's what we call API empowerment. Thinking about your business functionality as an API's strategy, to be looking at it as a strategic asset and surfacing that out first. A key portion of what we do is to do this best in class. And one of the things that is really exciting is, especially for like the ad chain use case, the throughput, the amount of compute. Well, stuff like serverless technology is becoming really hot. And the reason why is because, you know what, if I spin up that container or that VM or bare iron, I'm paying for it. I'm paying for the ops, I'm paying for the electricity, I'm paying for the compute, I'm paying for the cooling. But if I only incur what I really need to incur just for the sake of that computation, then I have the tightest discrete package for what it really should cost me. Now, the dirty little secret is, folks like Amazon with Lambda, it sounds great at this really low cost of compute, but when you really start to use it, well, guess what? It really starts to add up. And we're all about trying to give our consumers the power to say, yeah, I like Lambda, but you know what? Azure Functions is coming out. GCP, Google Cloud Platform will eventually catch up as well. And this thing will be commoditized. And you know what? I want to have my options open, because I don't want to be stuck into being locked into AWS Lambda rates. As great as they were when I started, as I grow and I scale, as my business grows and it scales, it gets to be a little expensive. All right, let's go straight into the demo as far as what Lunch Badger does. And I'll put it into the context building off of what James was talking about. So We'll run tic-tac-toe, and the great thing is you guys will be able to all do this. And we'll go through sort of the concepts in a little more detail as the physical structure and how it's laid out as far as architecture. So let me get out of this, and let's fire up the game. So what James did was he took this tic-tac-toe game and just ported it into JavaScript, right? And this is like one of the things that we can do. So let me minimize this a little bit. This is running off of our servers at Lunch Badger. And what we do is we provision you like a space. We call it the workspace. And this is an app running off of the workspace. So I have 2 windows, and I'm going to go ahead and play with myself, purely figuratively speaking. But let's go ahead and run this. So as you can see here, I have my first hash of the address. And that's why we want you guys to install MetaMask, because, again, this cryptocurrency stuff, your address is this long hash, right? Like, I think of addresses like, oh, 308 Beverly Drive, that's where I live. Well, no, this is your hash in Ethereum, right? This is your identity, your decentralized identity, right? And because I'm playing against myself here, so I'm going to go ahead and do this, and hopefully it'll work. Perfect. So I'm playing 2 players, player 1 on the left, player 2 on the right. We've both sent in our hashes. So we've both registered now to the observer. The observer is that judge that James was talking about. And the observer's job is just simply to say, well, I received one person's move and hash. I'm going to hash it, verify it, say, yeah, it looks good. It was from player 1. It wasn't from Bill trying to spoof or, trying to impersonate James, right? And I'm going to send that to player 2 to acknowledge number 1 and ask them for their move, right? So let's start with player number 1. So I'm going to go ahead and move here. So making move to transaction hash. And player 2, well, we'll go ahead and just pop down here. Okay, and as you can see, like we keep taking turns, right? As you can see for tic-tac-toe. So I'll move here, and eventually it'll show up there. There we go. By the way, this is all fantastic socket.io work that James did. And you know what? I'm going to go ahead and, oh, it's not my turn, see? Like I'm trying to cheat, and like the code's saying, nope, person needs to move. So let me go ahead and go here then. We'll make this contrived. Perfect. And now back to player 1. Okay, so player 1 has won. And simple game, the game is what we call the interaction. And you can think of the interaction as any use case you want to apply the off-chain experience. We've simplified this whole notion of off-chain and judges and observers. Like we try to extrapolate it to just something you guys can relate to. Like everyone can play tic-tac-toe, right? And it's pretty easy to verify who won, right? 3 in a row means you won, assuming that you guys took turns, right? So let's look a little bit behind the scenes now. Okay. So this is how tic-tac-toe is structured in Lunch Badger. This is what we call the Lunch Badger canvas. It's a friendly face to building microservices and APIs to surface your app. In this case, we have a set of microservices. The logic that embodies tic-tac-toe is based off of a contract, a game, and this thing called a transaction. And when you guys download the code, you'll be able to dissect this. But basically, it goes like this. And I'll bring up the diagram so I can talk to it. We have the 2 players. You have Chrome. Chrome is necessary to run MetaMask to get the ID. The first thing that happens is you spin up the game. So Lunch Badger runs this thing called a model. Models are basically our way of describing microservices. And the game model runs. That's the thing that registers and it surfaces out the tic-tac-toe game to the client, right? The second thing that happens then is we spin up the observer, the third party, the process that is going to go ahead and verify the hashes. And then the third thing that happens is when the observer then starts a transaction, again going back to James's presentation, the whole reason why this pattern works is because you're threatening to go on-chain. Think about that, right? So you can kind of think about this like in my latest blog post, I talked about an analogy that I think some of us can relate to, hopefully not, but like divorce. Going to court is extremely expensive, takes forever to get a court case on. If you're going to get a divorce, what do most people try to do? They try to go through the thing called mediation. Off-chain is mediation, compute mediation, to getting what you need done so that the only time you incur that resource for Ethereum is when it's intended for. There's a reason why it's called smart contract, because you're contractually obligated to honor what you intended to do, and it's for everyone to see in public eyes what you did do. That's the whole point of Ethereum. Ethereum's not there to sit there and run computations on tic-tac-toe, for crying out loud, and it certainly can't meet the use case needs for like ad tech. And you saw Facebook's 100 million requests per second. There's no reason why run Facebook necessarily on Ethereum. But Ethereum is there so that anyone who was interested in anything that ever happened, that needs that auditability, that trustless factor to say, yep, that's the single source of truth. That's what Ethereum's all about. So we spin up the contract. The contract then is injected through this connector that we built in LunchBadger to Ethereum test RPC. Test RPC is, you can think of it as virtualized Ethereum. So it takes that Solidity contract that says, Al and James entered into this contract to play tic-tac-toe. We call this first step memorialization. That is a public record to say, Al agreed to play James in tic-tac-toe, and we can take this one level further to say they both anteed $5 into this transaction, game, whatever. And a portion of that, going back to the gentleman's question about like, well, what's in it for me as an observer? Well, what's in it for you is that tax that James was talking about, right? So I'm the observer. I'm going to take 2, in this case for Ethereum, Ether off of 10 Ether that's been anteed up, and I'm going to internalize that for my services as the observer, which is basically verifying these hashes. So the contract is then memorialized. The 2 players go at it. As each player generates their move, a transaction is logged. And in LunchBadger, we have a thing called a memory DB. It's just a transient memory DB where we can store the results as things are happening. And we spin this all up as a service through our canvas. And you can kind of like logically see what's going on. Well, we have a contract. It gets stored in Ethereum. There's this game being served up. There's also an API for a transaction. And each transaction gets stored in memory. And then this entirety of itself is called what we call the observer microservice. And that's the thing that actually talks to this front end. So this is the pretty, I hope, back end to the game. We want to try to make it, even par, right? So going back to our diagram now, we've talked about each transaction. The observer is verifying hashes. At the end of the game, there's 2 outcomes. A player says, I'm the winner, and the other player either acknowledges, does nothing, or says, no, I dispute that. There's only really 3 logical outcomes, right? The observer then says, well, whatever the outcome is, what I have in my contract is what I'm going to do. So the observer then says, well, player 1 asserted that they won. Player 2 acknowledged. I'm going to pay player 1 the pot minus the 2 Ether. And then in real life, it costs money to actually run the transaction. That's the other thing that's part of the 10 Ether ante. And maybe the player gets, I don't know, 6 Ether as the reward, right? That's what's actually processed in Ethereum. That's the part that Ethereum is used for. And enforcing and threatening that you're going on-chain, that's the thing that makes this powerful and what makes it work. So you can think of the observer as like a public accountant, right? The person's livelihood depends on this particular function because they're trusted and they've done millions of audits. And they wouldn't screw over someone because that would basically put them out of business. And the fact that you're going to go on public record to actually memorialize and reconcile that transaction. That's why this pattern works. That's why it's necessary to understand this pattern and to use Ethereum for what it's intended for, and for the use cases like what AdChain's after and what the banks want for Ethereum for transacting and payment processing. That's why all this big draw around, and I hope that's why you guys are all here, to understand what is the practical tooling that gets me from this theoretical stuff with all this nascent technology and tooling to what I can actually do. And what's exciting is that you guys are on the forefront of trying to understand this. And to be honest, we're all trying to figure it out. Make sense? Yes, sir.
So when you're talking about a marketplace of observers, I know you have a contract between the players, but do you have a contract between the group of players and either one observer or multiple observers?
That's a great question. So I think we're trying to figure out what that marketplace means. But you think about what the observer really is. The observer is really is in code. The observer is the same as the game, but it's running in observer mode. And everyone has to agree on what that game is. If I say I'm playing tic-tac-toe Sumerian style versus tic-tac-toe Algerian style, like what the hell does that mean? So you have to agree on what that code is. And running the observer for that verification has to be par and parity to what it is. So that what that means is if I'm a participant, I can also be an observer because we have agreed on what tic-tac-toe is. And then in a room full of participants, 50 some odd participants, any one person can turn around and be the observer.
But if you're trying to go to using anonymous observers for transparency, you're going to need that observer to participate in the contract.
Yes and no, because when these transactions are sent, you have an identity that's that hash, and you really have nothing more, possibly, for the anonymity. But I would say if you are the observer, you're going to be recorded as far as that hash is, where the verification is, and it becomes kind of an anti-pattern because in the end, you want to notarize, you want to bear witness to what has actually been recorded here and what your role in participation is. Every person has that incentive, the players and the observer. And that's what creates the incentive for people to actually transact on the Ethereum, as well as the folks to say, yes, proof of work-wise or by verification through the observer mode, I bless this with my reputational stakes as far as being a participant in this ecosystem, because that person could also be playing tic-tac-toe, right?
Yeah. So I was just going to make a quick comment that I think, in terms of like the observer marketplace and being able to, ensure that you have trustworthy observers, there was a project called TruthCoin that was existing for like a couple of years ago, and I think it might have changed names, but I mean, the guy who invented it claimed to have the method that, you have multiple reporters who are kind of checking each other,
yep,
and were therefore incentivized to provide the right answer. There was some interesting math behind it that I can't exactly recall right now, but that was one way of kind of fixing that potential problem of observer collusion and things like that.
Yeah, that makes sense. Makes total sense.
Where are the servers for Launchpad located?
Our servers?
Yeah.
They're all on AWS. We built off of AWS, but we're fully cloud portable, and we use Kubernetes as our container orchestrator. So our first commercial customers, one of them being a large bank that I can't disclose, unfortunately, but basically they wanted to say, look, we love what you do on AWS, but we want you to be cloud portable, and we want you in our VPC, and we want you to do that in an open source way. And we said, great, check, 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 we do that. We use Kubernetes, we're fully container compliant, and you can run us wherever you want, either VPC or on Barrel. Yes, sir.
You have a database there, and even though in the blockchain you are registering the final outcome,
yep,
internal things are being drawn into that database.
That's correct.
Effectively, like Facebook or Google are actually accumulating data, that database is accumulating data of the people, which is an antithesis of what blockchain and Ethereum is all about.
Good point. This database is running as a memory database, and there is no persistence to it other than for what the observer can access.
That's the trust.
That's right. That's right. This entire thing has to be under the notion of a trusted environment. In fact, is that the next? I believe that's the next.
Like trust in banks for a very, very long time. So that's the problem. You don't trust in anything but what books.
Right. So no, that's a good point. I think what's happening is that when you break it down to transactions, you can use cryptography to ensure that the two players are signing and hashing correctly. So the trust isn't in the storage of the data, but the hashing and the verification that's going on per transaction. And as Al alluded to, Eugene's going to talk about some really exciting like hardware advancements that allow you to be able to verify cryptographically that the code that you wanted to run on the CPU is that code, even if like parts of the operating system were compromised. That would be a great question to ask Eugene. I'm not quite sure.
Any other questions? Cool. Oh, yeah.
So will you be expelled from the judge ecosystem if you have like a bad reputation? Is that a possibility?
Yeah, I think that's definitely a real possibility. Just like there's governing bodies for trade associations of reputations and the BBB, same concept, right? That there's a certain level of quality and professionalism expected, and there's a record now. Sorry, I switched slides, but in Ethereum as to who did what as well. So that's the other thing, right? If I were to go look at consumer reports or whatnot, that's a proprietary database. I think you can subscribe to that. Well, Ethereum's all public. And if that outcome of what actually transpired, because that is the source of truth, right, that's recorded, and people can look that up, well, that's a really powerful incentive to actually do what you intended to do. Now, it acts as a nice filter also to say, well, if you're going to go ahead and do something shady, most likely you're not going to participate. Which is also the great thing for that ad chain is all about. Because again, if you're doing fraud, you're going to quickly see who actually buys into ad chain and that notion and participates versus the folks who are like, oh yeah, I poo-poo on that. Oops, I'm running a bot farm, that's why, right? Similar concept.
And there's also, real quick, there's notions that, or ideas of game theoretics that you can use to properly incentivize. So you may not want to kick them out, but you charge a huge tax because now you have these platform signals that say, okay, well, this guy doesn't have a great reputation score. So it's somewhat like a Yelp like or whatnot. And so there are other ways to tackle this that are more based off of like general macro or microeconomics than just code.
So to conclude, learn more. The tic-tac-toe actual GitHub repo is made public now. In the prereq, we asked that folks go ahead and register on LensRag. It's completely free. We're in private beta. In fact, you guys are the public limited engagement for our products, and we're really honored to have you guys try it out. Our company is gearing toward public beta. So we're working closely with our what we call premier beta customers like Vidroll and AdChain, and we're trying to learn exactly about the API microservices use case, and that's what we're doing. Is just partnering and learning more so we can build out a better product. And if you want to get a hold of me, a couple of folks have asked. This is my Twitter handle, and of course I'm on LinkedIn as well. That's it for me. We have Eugene from Microsoft next.
Okay, we have trivia.
Oh, it's on.
Okay. Very happy that 3 people knew the answer to the first question. This one's a little more obscure, so maybe I'll stump you. We'll see.
Just shut this.